Can you tell if a system of linear equations is consistent, inconsistent, or consistent dependent? Let's take a look at a system and then figure out which definition would best describe this system. Here's our linear system. Now the first thing to notice is that the first equation in the linear system is written in standard form. We're going to have to rewrite that into slope-intercept form. The second equation is almost in slope-intercept form, but needs to be simplified. Let's work with the first equation first, and let's write it in slope-intercept form. Once we've written it in slope-intercept form, we'll be able to solve it and look at the slopes, and that will help us to determine what type of system this is. So let's start with negative 12x plus 4y equals 48. And the first thing we're going to do is add 12x to both sides. Remember, slope-intercept form means that we want to get y alone. And we're going to add 12x here. So these cancel, bring down the 4y. 4y equals 12x plus 48. Now we want to get y alone, so we can divide both sides by 4. Divide this whole right side by 4. These 4's cancel. Bring down the y. Y equals 4 goes into 12 3 times. That leaves us with 3x. 4 goes into 48 12 times. So we can write this first equation as y equals 3x plus 12. Now let's look at the second equation. We have 2y equals 6x plus 18. Now this is a lot simpler to work with because we've almost got the y by itself. To finish getting the y by itself, we're going to divide the left side by 2 and the whole right side by 2. These cancel. We bring down the y equals 2 goes into 6x, 3x, plus 2 divides into 18 9 times. Now these two equations make up our linear system. What do you notice about these two? Let's take a look at them and see. Now that we've simplified the linear system, you can see that these two values are the same. And we know that this value represents the slope of each line. So the slope of both of these lines is the same. It's 3 over 1. The y-intercepts are different. This first line will intercept the y-axis at 12, and the second line at 9. But the important thing to notice here is that the slope is the same. Lines that have the same slope are parallel. And parallel lines will never intersect. Because they will never intersect, we can't find a point of intersection that would work as the solution for both of these equations. So we can say that this is an inconsistent system. What if there had been a point of intersection? Well, that is a really good point. If there had been a point of intersection, then that point would have had an x-coordinate and a y-coordinate. The x-coordinate and the y-coordinate would have been a solution for the system. Because the system would have had a solution, we can say that this would have been a consistent system. However, because the slopes were the same in the system we were working with, it was an inconsistent system.